Now let's perform a working example on a data set. So we will solve the base problem now by hand, okay, so that you get a intuitive understanding of how this works. So if you look at it, this is basically one of the data set what we have. This contains like a type of mushroom. You can see that this is also another type of mushroom what we do have. We have a cap surface, cap color, bruises basically which are available, whether the mushroom have bruises or what is the order of this particular spot. Now this table what you have, definitely it contains multiple columns, but I want to keep it simple in the starting, and in order to keep it simple, what I'm going to do, let's assume that we do only have these two columns. I don't have any other column. I do have a column of type of mushroom, and I do have something called as another type of mushroom which have convex shape, bell shape, flat shape, right? So these are the shapes which are being available to us. Now let's see the problem what we are trying to solve, that assuming that only these two entries are available to us. The problem we are trying to solve is that we have the type of categories of a mushroom that we which is like edible, means the mushroom is good to be eaten, and the second type of mushroom is basically poisonous. So there are only two types of mushrooms which are possible here. So now let's say we want to figure out that basically I want to get the probability. I want to get the probability that basically my mushroom is edible. Okay, my mushroom is edible, means we should be able to eat it, given that the shape of the mushroom is, let's say, convex. Okay, so let's say I just got a new mushroom in front of me, and I can see that the shape of that convex of that mushroom is convex. Now I want to get the probability that whether that mushroom is edible or basically that mushroom is poisonous. So that is what we want to figure out. So in this case, if we look at this particular part, how we can define it with respect to our formula. So we can anytime say probability that my x belongs to convex, basically, which means that probability that the mushroom is going to be convex, given that it is edible. Okay, now this part you can get it from your training set, from your training data, the data which is already available to you. From there you will have all this information that we have already seen that when the mushroom was edible, then basically it was convex shape or not. So we already know about this, and basically then after that we will multiply it with probability that mushroom is going to be edible. Okay, mushroom is going to be edible divided by probability of x. Anyway, denominator is not going to be much of a matter here. So when I say x basically is this, right? So probability that it's going to be convex. So that's what I mean by that. So this is going to be my formula for this. Similarly, I can also get the probability of poisonous also here. So I can anytime say that probability that my mushroom is going to be poisonous, given that basically it's the mushroom in front of me is of convex type. So again the same thing, right? I can just say that probability that it's convex given that it's poisonous into probability that it's poisonous in divided by probability of this, right? So I'm not going to write it because it's kind of same thing which we have to basically define here. Now let's see the values, how we can compute all these values. So first of all, if I ask you what is the probability of mushroom to be edible, so let's look at the data. So if you look at it, I have total data into 14 entries. Like, so if you see this part, I have starting from index 2 to index 15. So there are total 14 entries. Now second thing, if you look at how many edibles are there in this, 1 2 3 4 5 6 7, which means probability that the mushroom is edible is going to be what? It's going to be 7 out of 14, right? This is basically the probability of this. Now second question is, what is the probability that it is a convex given that it is edible? Now first of all, given that it is edible means I want to get the sample space of edible. So sample space of edible, we have just seen that it's going to be 7. right? So we have already seen, learned that how to compute all of that. Now out of this, I want a common value where it is edible as well as convex. So let's see that. So this is edible and this was convex. This is edible and this is also convex. But edible, but this is not convex. Edible, this is convex. Is there any other edible? Yeah, there is one more edible and this is convex and nothing else. So this is going to be 4 by 7. So there are 4 occurrences where it is going to be edible as well as convex, and that's the reason I can get the probability like this. Probability that it's going to be convex, you can anytime go and compute it from here. I'm not going to computing it because you will notice that it have no significance actually in this case. Now this is the probability of it, and I will keep it like this only. So I'm going to say that I got the probability 4 by 7 into 7 by 14. So I'm going to cut it 7 7. So I'm getting what? 4 by 14 probability of convex. So this is the probability which I am getting for edible, given that it is a convex. Similarly, I'm going to compute it for poisonous also now. So for poisonous, let's compute it and we will see that what's going to be the output. So for poisonous, again the same story. So let's first compute that what is the probability that it's going to be poisonous. It's also going to be 7 by 14. So let's mark it as 1 by 2. Now probability that it is convex, given that it's going to be poisonous. So again the sample space for poisonous is 7, and if you will count that wherever it's convex as well as poisonous, so you will notice that there will be 3 numbers. You can go and check that it's going to be 3 number and divided by probability of convex. Okay, you can anyway check that it's going to be 3 number, the same way how I have done it earlier. So now in this case I will get the output as 3 divided by 14 probability of convex, right? So now 4 divided by 14 P of convex is greater than 3 divided by 14 P of convex. So that's the reason we can always say that since this probability is higher, which belongs to this, so that's the reason we can say that it's going to be basically edible kind of mushroom. You can go ahead and consume it. There will be no problem with this. So this is basically the way you can look at your probabilities with the help of this naive Bayes theorem. Now, interesting thing to note here is that when you're working with such sort of scenarios, basically you can notice that denominator is going to come common in both the case. So that's the reason most of the time when we have to do such sort of comparison, we always go ahead and ignore this denominator completely, because anyway if you compute, the value is gonna be same in both the side. So it's not gonna make any difference to give you the final output on the classes. So that's the reason we're gonna always ignore it for the same reason. So going ahead in future examples, you will notice that I'm gonna ignore this particular term for you. Now this is about when I have chosen only 2 columns. One was basically related to your final class, which was whether the mushroom is edible or not, and the second was what is the shape of that particular mushroom. Right now, in the further part, what I'm going to do in the next lecture, that I'm going to consider maybe one more column to it, and then see that how naive Bayes is going to work. And once we understood with the help of 2 columns, then you will understand that if I increase the number of columns to any number, it's going to work exactly in the same way, and you will understand the powerful and strength of your naive Bayes algorithm. So let's do that from next lecture.